Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section. And in the search question, search BST and hit enter. So, or let's try to search question like problem number 700. So problem number 700 says like there is a problem number 700 which says search in a binary search tree, and and it comes under the easy category, and it's actually very easy. So click on it. So search in a binary search tree. So we have given a binary search tree. We have to search. We have to search some element in the binary search tree. Right. So you are given the root of the binary search tree. So first we have to understand what is the binary search tree. But anyhow, we will look to this. So the root of the tree is given, and integer value is given. The value means like which we need to search, the element which we need to search. And if we found that element, so find the node in the BST, the node value equal to the value, then return the subtree. If we found the value, so let's suppose value is equal to 4. So 4 is exists. Then we are not going to return the true or false. We are going to return the node itself. Right. So not even the value, but the node itself. But if we did not find any element, then we are going to return null. Right. As an example, we have tree 42713. So we need to find 2, whether 2 exists or not. So 2 exists into this into this tree. Then we are going to return this node 2. So similarly, in this question, we have to like in this another example, we have to find 5. So whether in this tree 5 exists, no. So we are going to return none. Right. So let's go to the whiteboard. First, try to understand what is the binary search tree. So binary search tree, that is the BST. BST means binary search tree. So binary search tree is like the tree on which left, like all the elements on the left hand side are smaller than the root, and all the elements on the right hand side are larger than the root. So let's look at all the elements on the left hand side. So this is the left hand side, and this is the right hand side, and this is the root, and this is the root. So root is 4. So all the elements exist on the left hand side should be smaller. So 2, 1, 3 all are smaller. 7. So let's check on the right hand side. Right hand side, all the elements on the right hand side should be greater than the root. So root means 4. So 7 is greater than 4, which is correct. Now let's look at this tree. 213. So in the 213, if this is a subtree, so this should also follow the binary search tree property. So here 2 is the node. So if 2 is the node, so all the element exist on the left hand side should be smaller than the 2. So 1 is smaller than the 2. All the element exist on the right hand side should be greater than 2. So 3 is greater than 2. So which is perfectly fine. So this is the binary search tree, right? So like there are two approaches, like there could be multiple approaches, like we will see both the iterative and the recursive approach. So like within the iterative approach, like what we will do, we have given root is given, right? So we are going to run a loop while root. So while root, so first we are here, we will check whether the element at root is equal to the element which we need to find. If it is equal to, if it is equal, then straightforward we are going to return this element. That's it. If the element which we are going to find it is not equal to that, that is fine. If the element which we need to find is greater than this element, then where we need to find? Do we need to go here or do we need to go here? Right? So this is the binary search tree. We know in the binary search tree, like if the element is greater than the root, then it should exist on the right hand side. So if the element which we need to find is greater than this element, the root element, then we need to search here. Basically, we are like narrow down our search. So we have to search on the right hand side only. Right. So we have to search on the right hand side. So we will search in this tree. Then we will check, okay, whether element is equal to or not. Right. Similarly here as well. So if the element is smaller than the root, then we will not go right hand side. Then we will not go right hand side. We will go the we will go sorry we will go the left hand side. So we will, 1 second, we will search in this tree. All right. So let's try. So we have root is given. So we have to run a loop until we did not find the element. So while root, until the root exists, and there should be one element as per the constant. So the number of nodes in the tree should be 1 to 100. Right. So there should be one element. So there should be one root. So while root, then first what we will do. So we are here. We are here. So first we will check whether this value is equal to the value which we need to find. So if root dot value is equal to value, if it is equal to the value, then what we will do, we will just going to return the root, because we need to return the node itself. We need to return the node itself. All right. Okay, fine. L if let's suppose we need to search 7. So if we need to search 4, then here, like, the problem is finished. But let's suppose if we need to search 7, then what will happen? So this condition did not satisfy, then it is going to the elif. Then we will check if root dot value is less than value. If it is less than value, then we will make this 7 as a root. Then we will make this 7 as a root. 1 second. Then we will make this 7 as a root. Then root is equal to root dot right. So whatever on the right hand side, now that will become root. Okay. Else. So the third condition is if the value which we need to find is smaller, then we will make the left hand side as a root. Then root is equal to root dot left. Right. Then again it is going to search. So let's suppose if we need to search 7, first it will come here while root. Okay, we are here, fine. While roots, so root is not run, fine. We will go inside. If 7 is equal to 4, no, then we will going to elif. If 7 is greater than the root dot value, so 7 is greater than 4, yes. Now we will become root is equal to this. Then again while loop, so while root. So if there any element, yes, there is an element. Okay, then we will check. And then we will check whether root dot value is equal to value. Yes, 7 is equal to 7. Then we are going to return 7. So let's suppose we need to search 3. So we will first want the 4. So if root dot value is equal to value, no. If root dot value is less than value, no. Otherwise, so now root is equal to root dot left. So now root become this element. Right. So now we will check if root dot value is equal to value. So this 2 is equal to 3. No. If 3 is greater than 2, yes, then we will make this element as a root. Then it's going to run again. If root dot value is equal to value, yes, it is root is equal to value. Then return root. All right. So that's the end of the question. There is a one more condition. If we did not find, so let's suppose if this while loop did not return anything, it means we did not find our element. Then we are going to return none. So let's try to run it. So our like test case has been accepted. So let's try to submit. So our solution has been accepted. All right. So this is the iterative approach. Iterative approach means we are running some while loop. Now let's look at the recursive approach. So in the recursive approach, like we know we have to call the same function again and again, and there should be one base case. So what could be the base case? So if root is none, return none. If root dot value is equal to value, then return root. L if, then what we need to check, if root dot value is less than value, then we need to return. Then we need to return. We need to call. Let's suppose if we need to search 7, then we will call the same function by passing this as a root. Then we will call the same function. Same function means self dot search bst and root dot right and value. Okay. Else we will call the same function. search BST, but on the left node. That's it. So we are not running any while loop, but we are calling the same function again and again. So that's it. Let's try to run it. So our test case has been accepted. So let's try to submit. So our solution has been accepted. So that's the end of the video. It's like a very easy question. So you can try this question. Thank you.